Okay, hello. This is Dr. Janes, and today I'm going to talk about using this tunable inductor. I show how to build this in one of my videos. Free 3D printed part. I include the STL files. If you want to make your own tunable inductors. For my high-power audio circuit that I've been working on here for some of my crazy science experiments, and I wanted to move to inductors because, see, I've been using these tuning elements, these potentiometers. You can buy them; they're cheap. But the problem is they don't withstand a lot of power. You know, when you're powering NPN transistors, sometimes they want to draw a lot of power through the base, even. You know, most of the power is supposed to go through the emitter and collector because that's the main power path, but the base requires a lot of power if you're driving them at high power, so which I am, and I burnt out these guys before. They're lossy, right? Resistors are lossy, but inductors conserve your energy, so they're more efficient. So I would like to make a transition to this. I'm doing experiments with these oscillator circuits, and I just figured I'd do a little update if you guys are interested in designing high-power oscillator circuits for crazy science experiments. So let's get going. Okay, so here's my high-power audio oscillator circuit, and I was using this potentiometer in my tuning circuit here. Let's take a look at my tuning circuit. Here, take a look over here. Okay, so this is kind of what the circuit looks like, and this is where the potentiometer is. So I had an idea of adding an extra inductor, a tunable inductor, between the bases of the transistor. And it's probably hard to see, but that's what I'm effectively doing here, is adding. I showed in another video how to make this tunable inductor, and I was making one with less inductance because my calculations were saying it should have less inductance, but unfortunately my testing looks like it needs more. So let's take a look here. So this one, I forget the values of it, but it's in my video, and I'll remeasure it again. So let's turn it on. So we have the inductance, so this is all the way inside the inductor, and let's turn her on. And so we're getting a frequency here of around 16 kilohertz, and I wanted a bigger tuning range than that. Let's okay, I'm gonna screw this screw out all the way out, and okay, I'm gonna need two hands to do that probably. Okay, well, there we go. Anyway, screw this out. And the nice thing about using an inductor is they're low loss. These resistors dissipate a lot of power, and these transistors take a lot of power, and sometimes they burn out. These variable potentiometers have just a little fragile swiper thing in there that can't handle a lot of power. But these inductors can handle a huge amount of power. And I show in my other videos how to build these tunable inductors, and I did an update on a better design. I'm using springs in them now rather than gluing them onto the end, but if you have a strong enough glue it should work. I was gluing the inductor on the end of this guy, but now with this new design I put a spring in here so it doesn't have to be glued. It's just floating freely in there, and the spring just pushes it up. Okay, let's just see how much the frequency has changed when I've brought it to the lowest value of the inductance. Okay, and there we go. Let me I don't like to run this for too long, so I shut off the power. And let's move our cursors around. So that's about 19 kilohertz. So it's giving me a tuning range from about 16 to 19. And okay, so that's again, it's not as much tuning range as what I'd like, but these things handle a lot higher power. I might be able to do some switching into different ranges or something. So I'm going to fiddle around with this design some more, but I thought I might share that with you if you guys are interested in changing the circuit. I still have this guy in here, and you can still do some tuning with him, but I'd like to get rid of this component completely, because I've had issues with them burning out. So let me just kind of show you exactly what I'm talking about in this circuit. So here's our circuit here, and we'll take an inductor and we'll rotate it. So, oh, come on. Okay, so the idea is I'm connecting the inductor to the bases of the transistors, like so. I'll just draw this in quickly. So this is what our new modified circuit's going to look like. So that's from the one base of that transistor to the other base. So that's what our circuit looks like with our tunable inductor in here. And I guess that creates a resonant circuit through the transistor, because we have our inductor from our transformer. This is our transformer inductor. Remember, you can model the transformer as two inductors, and this is our load here. So it modifies this resonant circuit here. And so I think maybe I might look at switching some other inductors in, or shunting this out, maybe putting some switches. This just give us some tunability, which is nice. And I'm going to fiddle around with this design some more, and I'd like to make it a little bit more robust, a little bit high power handling capabilities. So, you know, like I said, this is kind of the limiting factor here. And I don't know if I mentioned before, but I'm working on some different devices. If you start producing high power scalar waves around these electronics, they don't like it. That's why I went to the 2 transistor oscillator, because low voltage electronics are disturbed by high power scalar waves. So anyway, very interesting. Oh, I didn't put my background up, did I? Put that up. Okay, so there. Now you can see the circuit a little bit better. So anyway, here's our tuning inductor, and I've taken it apart so I can work on it a little bit. But this is Dr. Janes, and thanks for watching.